Hello everyone, welcome back to my YouTube channel, and in today's video we are going to learn about what are linear equations in two variables. So today we are going to start the first chapter of linear equations in two variables, and in this video we are just going to understand what are linear equations, how to identify them, and how to write them in a standard form. So let us proceed. So what are linear equations? Okay, now since it says two variables, a linear equation is an equation which contains two variables, okay? Variables and the degree of each term containing variable is 1 is called a linear equation in two variables. Now when I read out this sentence to you, it becomes very difficult for you to understand, right? Let me just break down this entire definition, but before that, we'll just have a look at the example of the linear equation. Now if you look in this example, 3x minus 4y is equal to 0. We are just going to understand this definition or with the help of this example. Okay, so now an equation which contains two variables. Now in this equation of 3x minus 4y, can you see x and y? Yes, this x and y are considered as variables. Okay, so if any equation is having two variables, okay, and the degree of each term. Now where is the degree, children? Degree is always here in at the top. Suppose sometimes if you see there is square or there is cube on your alphabets or these variables, right? But when you don't have anything here, it means the degree is 1. Like in this case, the x in this equation, if you look at the x, there is no number at the top, so it is 1 here. Also there is no number at the top of y, which means it is 1. So the degree of this term, now what is this degree of each term? Now where is the term, children? Terms are separated by the mathematical operations. Like in this equation, 3x is your term, 4y is your term. Okay, so there are two terms. Okay, and if the degree is 1, see, if you see the 3 is there is only 3, means it is 3 raised to 3 is there, and x is there, right? So if the degree of the variable is 1, then you will say that it is a linear equation in two variables. So since this x and y both are having 1 as their degree, these equations are called as linear equations in two variables. So what are the necessary conditions here? First, there should be two variables, and secondly, there should be the degree of these variables should be 1. Okay, now let us proceed further and let us understand something more about these linear equations. Okay, so we're now going to understand the general form of equation. How do we write out the equation in a proper way, right? So let us see that ax plus by plus c is equal to 0 is the general form of a linear equation in two variables. So this, if you can see here, I have highlighted the a, b and c with red color, right? Which means that these a, b and c are going to be the numbers. Okay, now a and b will be the coefficients of x and y, whereas c will be a number. So there are certain conditions, but there are certain rules which are necessary to be followed for a linear equation. Now if you write down the equation in such form, then it is very necessary that these a, b and c are real numbers. Okay, and a and b cannot be 0, means the coefficients of x and y cannot be 0. Now what about the real numbers? You might have forgotten what are real numbers, so let me tell you what are real numbers. Real numbers are normally the combination of rational and irrational numbers. Rational numbers includes negative and positive numbers and fractions, right? Whereas irrational numbers, we have already seen in the ninth standard, these are the root 3, root 7, or these pi. These are all the irrational numbers. So you can have any number there in place of a, b and c except 0. Okay, now, and a and b cannot be 0. Okay, so now, like for example, if you get an equation anytime like 3x is equal to 4y minus 12. So if I arrange this in a general form, how do I write this? So I need to write down like this: 3x minus 4y plus 12. I bring all of them to the left side. How do I do that? So for that, what I need to do is I just see from the right side this 4y goes here, so it becomes minus 4y. Similarly, from 12 plus 12 goes to the left side, it becomes plus 12. Okay, so minus 12 goes there, it becomes plus 12, plus 4y goes there, it becomes minus 4y. So this is how we write down the equation in a proper form. And let us proceed ahead now. So using this entire knowledge, we have to solve this activity and learn to identify whether these out of these 7 equations, which of them are the linear equations in 2 variables. So let us recollect the points that we have learned. See, an equation to be a linear equation, it is very necessary that it has 2 variables, and the degree of these variables should be 1. Also the coefficients, the numbers in a and b, like the coefficients of the variables cannot be 0. Okay, and at the same time there can be anything else apart from 0. They can be real numbers, any real number. So let us see if there is an equation which satisfies all of these conditions, and if there is an equation like this, then it will be called as linear equation in 2 variables. So now let us have a look at the first one. So let me check. I have 2 variables m and n, right? I also have their coefficients. A and B are not 0, 4 and 3. We have 4 and 3 which are not 0, and they are real numbers, right? So yes, these are the linear equation, even though it is not in the standard form. But yes, this we know that this is 4 is A, 3 is B, and 12 is C, right? So they are all real numbers, and hence we say yes, 2 variables are there with degree 1. Now let us have a look at the second equation. Now what do we find in the second equation? We have 3x square minus 7y is equal to 13. Now in this, if you look at the variables, the variables are x and y, not an issue. But look at the degrees. The degree is 2, whereas the degree of y is 1. Okay, so in such case, what happens is, since we don't have degree of x as 1, it's 2, right? We cannot say that it is a linear equation. We will say no, it is not a linear equation because the degree is 2. Okay, now third one, root 2x minus root 5y is equal to 16. So as per our rule, we have x and y. We also have their degrees as 1. Yes, and also root 2 and root 5 is there. Root 2 and root 5 are the irrational numbers, and are conditions say that it is okay to have any other number except 0. So yes, this will be a linear equation with 2 variables since the degree is 1. Now let us have a look at the next one. In the next question, we have 0x plus xy minus 3. Now here we have x and y as the degree, not as a variable, not a problem. Also their variables are 1, but just have a look at their variable. The coefficient of x is 0, which is not allowed. Yes, this is not allowed, and hence we say that no, this is not a linear equation in 2 variable, because we will be left only with 1 variable. Why? Because if this is 0x, it means that it is 0 into x, right? And anything multiplied by 0 is equal to 0. So instead of this entire 0x, we'll be left with only 0, right? So we will be having only 1 variable, 6y minus 3. That will be the only equation left, and hence we cannot say that it is a linear equation in 2 variables, because there are no 2 variables in this question. Okay, so that is why this is not a linear equation in 2 variables. Now next one, let us have a look at the next question. 0.3 plus 0y minus 36. Now regarding the variables, yes, we have x and y with the degree 1, not a problem. But the coefficients, you may say 0.3 and 0. See, firstly, since we are having 0, it is not a linear equation. You might be thinking, what about 0.3? Is 0.3 okay? Yes, we have already said that it can be anything except 0, right? Or in other words, if you see 0.3 can also be considered as 3 upon 10, right? 3 upon 10. So the fractions are allowed as per our conditions. So hence there is no problem with 0.3, but since we are having the variable of y as 0, we cannot use that to solve our we cannot consider it, and hence we say that this is not a linear equation in 2 variable, because since there is 0y, it will go away, and what will be left, only 0.3 x will be left, and we will be having only 1 variable in our equation. Now next, 4 upon x plus 5 upon y is equal to 4. So See, if you see here, our x and y are in the denominator. Now, everywhere else, if you see the equations, the alphabets or the variables are in the numerator, or they are in the proper form, right? So here, x is not in the numerator, or you can say, now in this case, if I try to bring this x up, if this x goes up, according to the rule of indices, we have learned this in the 7th standard, 1 upon a raised to minus 1 is going to be equal to a. Yes, when this will go up, its sign will go and it will become a raised to, a means a raised to 1, right? This sign changes. Suppose I have 1 upon, say, 2 raised to 3. So if this goes up, this will become, I suppose if I have 1 upon x raised to 3, I'm so sorry, if I have 1 upon x raised to 3. Okay, so if this goes up, it will become x raised to minus 3, right? So similarly, when this x will go up, here the degree is 1. So when it will go up, it will become x raised to minus 1. And similarly, when this y will go up, it will also become equal to minus 1. And hence, we will get our equation as this. 4x raised to minus 1 plus 5y raised to minus 1 is equal to 4. Since we are having the degree of x and y as minus 1 and not 1, we say that this is not a linear equation. Our condition says that we can have only 1 as its degree. So since we have here minus 1, we cannot consider it as linear equation in two variables, and hence we say no, that the degree is of the variable is minus 1. This is the reason, and hence this is not a linear equation in two variables. Now lastly, seventh question is little different. If you look for the terms, the first term is 4xy and the second term, if you see, it's 5y. There is no problem with 5y, but if you refer the first term 4xy, what we find? If we find out the degree of this, see here x is having the power 1 and y is also having power 1 separately, right? So what happens? The degree of this entire term becomes 2. We add the powers 1 plus 1 2. Okay, if so, hence in this case what happens, the degree of 4xy will be equal to 2, and hence we cannot consider this as linear equation, because our linear equation says that we can have only one as a degree, but here since there is x, there is also y, and hence we are adding their powers, the degree of this term becomes 2, and hence it will not be a linear equation in two variables. See here, if I have, you can see on the screen that it is 4x raised to 1 and y raised to 1. Since x raised to 1, y raised to 1, the number 1 will get added. Okay, and it will be resulting in degree of xy, which will be equal to 2. So hence we say that these are not the linear equations in two variables. I hope you all have understood whatever we have done in this video.